Hey guys, welcome to Unit 13, Lesson 3. Topic today is converting from polar to rectangular coordinates. I would like you to pause the video and try the warm-up. Okay, so if you look at the warm-up, it's asking us to find the exact value for each of the following angles. So again, I'm going to work in radians and I want you to get used to the fact of that your angles are given in radians and how to use them. So 2 pi over 3 is, I'm just in the second quadrant, it's 120 degrees, second quadrant. So how do we do this? Going back to what we did in, I think, Unit 7. Your initial ray is always glued to your x-axis. Your terminal ray would be with the exact angle, so that's 120 degrees. You actually work off your reference angle. Your reference angle is between the terminal ray and the x-axis, which is 60 degrees. How did I get that? This was 180 degrees. This is 120. So 180 minus 120 is 60 degrees, right? And also, we need to know about the acronym ASTC, which means that the trig function S stands for sine, and sine is positive in the second quadrant. So my answer would be positive. So remember, we used to do QSFR. That's what we're doing here. So quadrant, I'm in 2. My sine is going to be positive because I'm in the second quadrant. Sine and my reference angle is what? 60. So basically, sine of 60 is rad 3 over 2. So that's my answer. Cosine 5 pi over 4 is 225 degrees. I'm in the third quadrant. Let's do our QSFR. I'm in the third quadrant. Let's sketch it. 225 in the third quadrant. What would be my angle? My angle would be pi over 4 or 45 degrees. So my sine is going to be cosine. Again, ASTC. The third quadrant, only tangent is positive. So your sine is going to be negative. Your function is cosine and 45 degrees, or pi over 4, you can say. So which is going to be negative rad 2 over 2. You can do your exact value table and remember this values from there. Okay, so now sine of negative pi over 6. Again, sine of negative pi over 6 is sine of negative 30. Your negative pi over 6 is in the fourth quadrant, which is same thing as 330. Your reference angle is what? 30. Remember, your reference angle is always positive and acute, right? So I'm going to do QSFR. My quadrant is fourth. Sine is negative because only based on your ASTC in the fourth quadrant, only cosine is positive, so sine is going to be negative. Your function is sine and your reference angle is 30. So negative sine of 30 means sine of 30 is 1/2, so it's going to be negative half. Cosine pi, these are your quadrantal angles. You should know these. So this is 1, 0. Opposite would be negative 1, 0. This is 0, 1. And this is 0, negative 1. Cosine is your x coordinate, so cosine of pi is negative 1, right? So you can actually use the calculator also for these, but I'll always sketch it out and you can do it. Okay, so polar versus rectangular coordinates. Remember, your polar coordinates are written as r comma theta, and your rectangular coordinates are x comma y. How do we convert polar to rectangular? So you will be given something as r comma theta and you want to write it as x comma y. So by applying trigonometry, we can find equations that relate the polar coordinates to the rectangular coordinates of a point P. So to convert polar coordinates, which is to rectangular, r comma theta, what do? You do is, you of course are going to write it as x and y. The formula for x is r cosine theta and formula for y is r sine theta. This is not something new. You have been doing it for quite some time, going back to our unit circle. Remember, your radius was 1 in unit circle. That's why your x was your cosine, your y was your sine. But this time, I'm saying this is not a unit circle, it's a circle with radius r. So what would be cosine theta? So let's write this down. Let's derive how we're getting those things. So cosine theta, I'm going to do it here. Cosine theta, if I was to do the ratio for cosine, is adjacent over hypotenuse, so which is x over r. If I was to cross multiply, what do I get? X is equal to r cosine theta. So it's literally from there. So if you ever forget, it's a quick way of finding it out. Sine theta, ratio for sine theta is what? Opposite, this is your theta. So opposite is y. So y over hypotenuse, which is r. So y is going to be r sine theta, where theta is your angle, whatever that angle will be. Okay, it's which will be given to you, which we get from here. Okay, so it's that simple. So please know your exact value chart. If you want to sketch it out, it would be a great idea. So let's do the first 3 questions. That's what I'm going to do with you, or example 1 and 3 parts of it. So it says 2 comma pi. So again, first thing you need to do is identify what's your r and what's your theta. And you know x is r cosine. Again, remember x goes with cosine, and y is r sine theta. So all you're doing is substituting in. X equals 2 cosine pi. So cosine pi is 180. Cosine of, again, sketch it real quick. Cosine of 180 is what? Cosine is the x coordinate, it's -1. 2 times -1, so x is -1. Y equals 2 sine 180, or pi, which is sine of pi is 0, so 2 times 0 is 0, so y equals 0. You're not done here, it's asking you for the coordinates, so please make sure we write down our coordinates. So your coordinate is -1 comma 0. Okay, always write out your coordinates. The second one, again, it's r comma theta. So it's going to be x equals r. I'm going to write my formula for each one so that we have it memorized. So x is equal to rad 3 cosine pi over 6. Pi over 6 is, you can either substitute pi with 180, or pi over 6 is 30 degrees. We need to know that. Rad 3 comma 30. So what is cosine of 30? It is rad 3 over 2. Rad 3 times rad 3 is just 3 over 2. So 3/2. Right? Now I'm going to do similarly. Y is equal to r sine theta. My r is rad 3 sine pi 6, which is 30. So y equals rad 3 times sine of 30 is 1/2. So y is going to be rad 3 over 2. So write down your points. It's x, which is 3/2, rad 3 over 2. That's your point. And the last one, -5 comma 4 pi over 3. So pi over 3 is what? Let's quickly do this. Pi over 3 is 60, so 4 times 60 would be 240. So it's 240 here. And you have a reference angle of what? 60. Right? I'm going to do my QSFR. So I know my exact value. I'm in the quadrant. 3, my sine, ASTC. Right? I'm going to do first this is for cosine. And then I'm going to do for sine. It's going to be negative, actually. It's going to be negative for both. It doesn't matter. And then my function is cosine. And my reference angle is going to be 16. So cosine of 60 is what? 1/2. So it's going to be -1/2. Right? So let's do that. So x is equal to r cosine theta. So I know this is r, this is theta. So x is equal to -5 cosine 4 pi over 3. We already found the value for 4 pi over 3, which is -1/2 1/2, right? We said cosine of 60 is 1/2, and this would be 5/2. Similarly, we're going to do the QSFR for our sine function. QSFR, I'm in the third quadrant, sine's going to be negative, function is sine, reference angle is 60, so sine of 60 is rad3/2. So I'm going to find, that'll help me find my y, because y is r sine theta. I just found my sine theta, which is what? Negative rad3/2. Didn't write the negative here. And my r was what? -5, which would be 5 rad3/2. So am I done here? No, I have to do what? Write it as one point. So it's going to be 5/2 x coordinate and then 5 rad3/2. So this is how you convert from polar coordinates to rectangular coordinates. Okay, so I want you to finish the remaining questions. They're not that many, but make sure you show all the work, sketch your QSFR for if the angle is greater than 90. So good luck